will be section 0.1 in Geometry Day 1. What we're going to do today is just do some algebra review from last year, just to get us going for this year in geometry. So we're going to set up the equation. We have the equation 5x plus 3 equals 23 set up, and we're going to solve that. So what we're going to do is we're going to use the addition property of equality. In fact, it would be the subtraction addition of equality, because this is plus 3, so to get rid of that, we want to subtract 3. So we'll subtract 3, but remember, if we do it to one side, we have to do it to the other. So that's gone, and then on the left side we still have the 5x equals. On the right side, 23 minus 3 is 20, and then we have a 5 times x, so we want to get rid of the times 5, so we divide, and that is the division property of the equality. So we divide both sides by 5, so x is, what 20 divided by 5 is 4, so x is 4. Now last year you probably were made to check that. We're not going to check that because that looks right. We can check it real quick mentally if we want to. 5 times 4 is 20, 20 plus 3 is 23, 23 equals 23, check. Right. So let's move on to the next ones. Now what we have is we have our variable a on the right side. So we have 3 times a minus 14. So we want to do backwards of what our PEMDAS told us to do. We want to get rid of the minus 14, so we add 14 to both sides. Now here in a second, we're going to quit doing these little baby steps and showing all these little baby steps, but for now we'll go ahead and do that. So what we have is 4 plus 14, which is 18, equals 3a. And then we divide both sides by 3, divide by 3. That's Gandhi. So what we're left with now is, on the right side, is a. And what we're left with on the left side is 18 divided by 3, which is 6. Now, I don't like writing it like this. It's not wrong, so you could leave this as the answer. I like to use the symmetric property of equality, which states that, hey, you can flip-flop that about the equal sign, and it's still the same. So a is 6. Okay. So now, let's go ahead and move on to number 3. So we're going to subtract 5. So now what I said, I'm not going to show all those little baby steps. I know that you know that you're going to go ahead and subtract 5 to get rid of it. So let's go ahead and do that. I'm still kind of showing my work. I'm just not showing those little baby steps along the way. We know that we have 2 times y, so we know we're going to divide by 2. So that would cancel out. 14 divided by 2 is 7. So our answer there is y is 7. We could mentally check it real quick if we were with a calculator. 2 times 7 is 14. 14 plus 5 is that 19. You betcha, check. So we know we're right with just a little quick mental check right there. Alright, let's go on to numbers 4. So again, what we have here is we have a 6 plus 5c, our variable being c, on the left side. So I'm going to get rid of that positive 6, get rid of positive 6. I know I'm going to subtract 6, so what we'd have is we'd have 5c equals, that's Gandhi. That's going to be negative 35. Be careful with those negatives. So we're going to go c equals, we're going to divide by the 5. Negative 35 divided by 5 is negative 7, so our answer is negative 7. Alright. Now, you can go ahead and do 5 and 6 there. I'm going to jump down here to number 7. So if you want to do 5 and 6, pause it. You may. I'm going to go to number 7. So what we have here is now we don't have just a plus and a minus and a multiply. We have a n divided by 3. That quantity is we subtract 8 from that, and that equals negative 2. So we should know that the first thing we're going to do is get rid of that minus 8. So we know that to get rid of the minus 8, we're going to add 8 to both sides. And then what we need to look at it over here is, what is negative 2 plus 8? Well, that's just like saying positive 8 minus 2. That is 6. Now here's the trick to this guy. The trick to this guy is this is n divided by 8. So how do we get rid of a divide by 8? We multiply both sides by 8. So that's going to be gone. So we have n equals 6 times 8, which is 48. So our answer to this equation is 48. So now if we wanted to check it, we could do that as well. We could throw that 48 in there, 48 divided by 3, and subtract 8 from that, and we would get negative 2. Oh, that's my fault. Yeah, we're good. Okay, so let's go over to number 8 now. Number 8, we do the same thing. We have a 5 here, a plus 5, so we know we're going to subtract that. So we have x over 4 equals negative 4. We have that same little trick here where we have that x over 4. That's a divide by 4. So to get rid of a division, we're going to use the multiplication property of equality. We're going to multiply both sides. Because I do both sides, again in algebra, if we do it to both sides, it still stays true. So it's minus 16. X equals negative 16. Double check it, throw it back in there, good to go. Right. Let's do the same thing on number 9. We know we're going to add that 4. Now I'm going to put that negative down here with that 3. So we added 4 over here, so we'd have 17. Now I want to get rid of that divide by negative 3, so again I'm going to multiply both sides by negative 3. So that way I can cancel out the negative and the 3 all at once. So we take 17 times negative 3, that's going to be negative 51. So there is our answer there. And again, we could do a quick mental check or throw it in our calculator to double check ourselves if we wanted to. Alright, so let's go through 10 and 11, a couple more of these, or let's do one more of these. So let's do number 10. So we have d over, now remember I'm going to write that as d over negative 6. Now sometimes it's better to see that negative up top, sometimes it's better to see it down low. I just like to see it down low on this one. I know to get rid of that plus 12, I'm going to subtract 12 over. So I'm going to have negative 7 minus 12, which would give me negative 19. To get rid of that divide by negative 6, I'm going to multiply both sides by negative 6. Now these are the baby steps that we don't necessarily need to show, but we need to keep nice, neat, and organized in our work. So d is equal to a negative times a negative is going to be positive. So we take 6 times 19. Remember 6 times 10 is 60. 6 times 9 is 54. So that would be 114 as our final answer there. Okay, so you can pause this. You could do it 11 and 12 and double check your answers. Alright, so let's go down to 13, 14, 15. The difference between these guys now is if you look at this, we have a variable on each side. So what you were taught last year is that you need to get those variables on the same side. Now I'm a positive kind of guy, so I try to keep my variable positive if I can. So if we look at number 13, I want to move my variables to the right. Now I know that because if I do that, I'm going to be positive with my variables, and that's what I'm looking for. So what I'm going to do here is I'm going to add 3x here. And again, these are the baby steps that we may not need to show. So that's Gandhi. So what we have then is we have negative 4 equals, we have 7x and 3x, which is 10x. We have a minus 6 there, okay? Now what we need to do is get rid of this minus 6. So we took my variables to the right side, so I need to take my numbers to the left. So I need to get rid of this minus 6, so I'm going to add 4. Or sorry, add 6, Gandhi. Negative 4 plus 6 is 2. I still have that 10x on the right side. Now I need to get rid of that times 10. So I'm going to divide this by 10. Divide this by 10. That's Gandhi. So what I have is I have 2 over 10. Now 2 over 10, you can divide that to calculate, but you don't need to. Just simplify that fraction. So we look at 2 over 10, we simplify that. That is 1/5. So x equals 1/5. Now I didn't mention it up here, but I did use that symmetric property of equality, meaning that I can flip-flop the equal sign around that and be fine. So I could have x equals 1/5 or 1/5 equals x. Okay. So there we go. I'm going to skip number 14 and let's go to number 15. Give me a little bit more room to work. Alright, so number 15, I want to get my variables to the same side. And again, I'm going to try to stay positive. So I'm going to try to keep my variable positive. In order to do that, I'm going to get rid of this minus a. So to do that, I'm going to add a. Golden rule of algebra, we do it to one side, we have to do it to the other side. So what we're left with is 20 equals 10a minus 2. I need to get rid of the minus 2, so I'm going to add 2. Add 2. Gandhi. So we had 22 equals 10a. Now if you're good with numbers, you notice that this isn't going to be very pretty. So we're going to divide by 10. Divide by 10, we're not going to get a nice pretty integer or whole number here. Now we could do one of two things. I could simplify that as a fraction and just leave it, and that's what I'm going to do real quick. That's going to be, take each of those as half. That's going to be 11 over 5. Or if we wanted to, dividing by 10 is real easy because when you divide by 10, you just take that decimal place 1 to the left. So that would be equal to 2.2. Okay. So I'm good with either answer. I always kind of like the improper fraction because right there, that's a lot less work. We didn't have to throw it in the calculator. We just simplify it, and we're done. Now, these guys right here, 16, 17, and 18, 16 and 17 especially, we see these guys and we see fractions. And that's going to scare some people because some people don't like fractions. So what we're going to do is you learned last year that you could eliminate the fractions using a nice pretty acronym called LCD, the lowest common denominator. So if we look at these fractions, 2/3 and 1/6, my denominator here is 3, my denominator here is 2. Now, to find the lowest common denominator, you look at the largest one, 3. The largest denominator is 3. Does 2 go into 3? No, it doesn't. So what you do is you go up in multiples of that 3. Okay, so the next multiple of 3 is 6. Does 2 go into 6? You bet you it does. So my lowest common denominator is 6. So what I'm going to do is I'm going to take that 6 and I'm going to multiply every term. Now notice how many terms there are. 1, 2, 3, 4. Remember from algebra last year, what separates terms is plus, minus, equal sign. Okay? So I'm going to multiply, since I have 4 terms, I'm going to multiply by 6 every time. Now some teachers will tell you, hey, put parentheses around that, just put a 6 times out here and distribute it. I don't like doing that. I like to show it at times every term just so I don't forget. Now, what we're going to do is we're just going to take 6 times 2/3 real quick in our head. Now, when we take a number times a fraction like 6 times 2/3, what we can do is we can take that 6 times the numerator, 6 times 2 is 12, over 1 times 3, which is 3, and we can just take that 6 times 2, 12, 12 divided by 3, that is 4. Because we multiply by the lowest common denominator, these fractions are going to vanish. So I'm going to go 6 times 2 is 12, 12 divided by 3 is 4, so I have 4 in, even though we're in the United States, plus 6 times 8, which is 14, equals, now here we go, this is 6 times a half. I hope you know that 6 times a half, half of 6 is 3 in, plus 6 times 2, which is 12. Now we're right back to the problems that we were doing previously where we have a variable on each side, but everything's nice and pretty. Now in this one, I'm going to move my 3 in to the left so I can stay pretty. Now to keep that 3 in, to move it to the other side, it's positive here, so I need to subtract 3 in, subtract 3 in. Now, some of you are pretty good at algebra, and you'll figure this out, that, hey, that's going to cancel out. I'm left with n, and then on the left side, I'm also left with that plus 14. Well, you know that the next step you're going to do is add 14. Well, let's just save that step and do it with this one. So we know we're going to have to subtract that 14 over. So now I'm trying to save you some room and some effort here that we can just go, all right, 4n minus 3n is n. 12, positive 12 minus 14 is negative 2. There's your solution. So we save that whole step of having to rewrite it and then subtract the 14 and then rewriting the answer as n equals negative 2. So to me, that's just an easier way of getting it done, just a little quicker. Okay, still showing my work, still nice, neat, and organized, but there we go. So now if we look at number 17, same process here. I have those fractions. And some of you are like, oh, fractions, I don't like fractions. No problem. We're going to look at them. I have the same denominator. That makes it nice because if you have the same denominator, your lowest common denominator is that number. So my lowest common denominator is 5. So I'm going to multiply every term, 2, 3, 4 terms, by 5. I'm literally going to take that every term times 5. Now this is really cool here. 5 times 2/5. I always say in algebra, when you take a number like 5 times the fraction of 2/5, you can actually put that number in the numerator. Well, if you look at this 5 times 2/5, those 5's actually cancel out, and you're just left with the 2. So we're actually just left with 2y minus 5 times 8, which is 40. Please do not forget to do every term. That's the biggest mistake when we're doing this. 5 times 9 is 45. Same thing happened here. 5 times that 3/5, those 5's are going to cancel out. You're just left with minus 3y. Okay, so now we're to that same point where we have a variable on each side, but they're nice and pretty. Okay, so what I'm going to do is I'm going to take this 3y, this negative 3y, and I'm going to add 3y to this side, add 3y to this side. Now I'm going to show my baby steps on this because I'm going to do multiple steps at once. Okay. So now again, if we rewrote this, we know that we're going to have 5y, and then we're going to have this minus 40. Well, we know to get rid of that minus 40, we're just going to add 40. So I'm going to do it at the same time to both sides. Now, nice and neat, that's 5y. 45 plus 40 is 85. So now we go divide by 5. So we divide that by 5, and we find that the answer is 17. So y equals 17 is our answer. We could go ahead and throw that in our calculator and put that y value in for there, and we could check it really, really easy with our calculator. Okay. Let's go over to number 18. This is another special case here. This is kind of a goofy guy. We have a variable on each side. So you guys are going to go ahead and start on this, and you know you go, alright, I got to get -4 over here, so I'm going to move it to the other side. I'm going to go +4r. Now I'm going to do the same thing over here. I'm going to go +4r from this guy. Now if we wanted to, we could do our two steps at once. I see a 5 and a 5, so I'm going to go -5, -5. Well, if you start canceling out, that's gone. And 5 minus 5 is 5. So to hold this place over here, since nothing's there, that's 0. Same thing over here happens. If you have -4 plus 4, that's gone. That's 0. 5 minus -5 is 0. So we have 0 equals 0. So what I always did in algebra is I asked the question is, all right, we have this equation 0 equals 0. Well, when does 0 equal 0? 0 always equals 0. So what this means is that we have a solution no matter what. So this is always true. Okay? So, or we could just say all real numbers. What that means is that no matter what value of r, you know, I could take r as 10, I could take r as -5, I could take r as 1,000, whatever I wanted, and if I substituted those r values in there, what's going to happen is I would get the same thing on both sides. Let's say I took 10 in there. That'd be -40 plus 5, that's -35. I would automatically get -35 here. And that's a true statement. If I took -5, that's going to be 20, 25, and 25, so I'd have 25 equals 25. Well, that's a true statement. No matter what we put in here for r, this statement, this equation will always be true. So that's what's going to happen if you get something like that, where 0 equals 0. Now, on the other side of that, I don't know, if we get something like this, if we solve this equation and we get 0 equals 10, when does 0 equal 10? Well, that's never. That's never, so this would be no real solutions. No real solutions. Alright, so if you get something like 0 equals 10, that's never true. That means no matter what number you plug in there, there's not going to be a right answer. Alright, and if you get 0 equals 0, then that's always true. Alright, so kind of a goofy situation there in both those cases there. Now let's go back to some of the graphing that you did last year, and this is just the basic graphing. We're out of the baby steps of doing the whole x, y, t chart because you guys learned the slope-intercept form, you learned the x and y intercept methods last year, so let's review that. So we want to do two things. We want to write an equation in slope-intercept form, and then we want to go ahead and graph that line. If you remember what slope-intercept form, we're going to write that real big, bold, and beautiful down here, y equals mx plus b. That's the one equation you'll graduate from high school and you'll be on your deathbed and you'll remember that. What's slope-intercept? Y equals mx plus b. Alright, so when we go this, the m value in y equals mx plus b, that is your slope. So a simple way of thinking your slope is if you're putting money in your piggy bank and you have $100 in your piggy bank and you're adding $5 every week, your slope, your rate of change would be that $5 that you're adding every week. Okay. Now the b value here, that's your y-intercept. That's your starting value. So at 0 weeks, how much money did you have in your piggy bank? You had $100 in there. Okay, that's your y-intercept. So when we go to graph this, I'm giving a slope of 2/3. That goes there. And a y-intercept of 5. That goes right there. So very, very easily to write this equation, we're going to go y equals my slope is 2/3 x plus 5. So when we go to graph this, we're going to go to the ordered pair of 0, left or right. Remember, when you plot points, you go left or right first. So we go 0, left or right, and 5 up. That's my y-intercept, y, because it's on my y-axis. Right. Now, from that value, that's where we count slope. Now, remember, count slope, we go rise over right. So from this y-intercept, I'm going to rise 2, and I'm going to run 3. Now, I like to do several of those just so I get a good picture of what that graph is going to look like. And then what you need to do is you need to take your straight edge and go ahead and draw that line right through there. Nice, neat, and pretty. Extend the graph the entire distance through your plane that you have. All right. Now, remember your arrowheads, because that line's going to keep going forever and ever. You know, if you keep putting $5 in your piggy bank, keep putting $5 in your piggy bank for the rest of your life. Okay. Actually, you're probably going to die and quit doing that, but theoretically, you can keep putting $5 in there. Okay. So that's slope-intercept form of the equation, and that's the graph of that line. So let's go to number 20. Let's write a quick slope-intercept form. So we're going to go y equals negative 7/3 x plus 1. So we're going to go up 1. Now from this ordered pair, that's my y-intercept, so we go up 1. Now from that, we're going to go down 7 and right 3. Now if you notice, if you're graphing this and you try to go down 7 again, you're going to be off the chart. Okay, well, let's not do that. Instead of going down 7 and up, or right 3, that's a negative movement and a positive movement, we could go up 7 and left 3, because that's still a positive movement and a negative movement, so we still have a negative movement overall. So let's go 1, 2, 3, 4, 5, 6, 7, up 7, 1, 2, 3 to the left. There we go, and I can't do it again because I'd be off the charts again. So we can go ahead and graph that, take your straight edge, and draw that line. Remember to put arrowheads on each end because theoretically this is going to go on forever and ever. Amen. All right, so it's slope-intercept form. Now, if we look at number 21, this is not in a nice, pretty slope-intercept form equation. Slope-intercept means that that graph is solved. That graph is solved for y, but this graph is not solved for y because it's got y and x on the same side. It's got a 5 in front of the y. So we need to put this standard form equation in slope-intercept form. Now to do that, the first thing I need to do is get my x over to the other side and away from my y value. So we have a minus 2x. Well, just like we were earlier, we're going to add 2x to the other side, and we'll rewrite that. So that cancels out. So now we're left with 5y on the left equals, that's a positive 2x and a positive 15. Okay. Now we have this 5 times y. So we need to get y by itself. So get rid of a 5 times y. We just simply need to divide by 5. And we have 3 terms. So just like we were earlier, we're going to divide every term by that 5. Divide that by 5. Divide that by 5. That works out pretty. So that cancels out. What we're left with on the left side is y equals, that's 2/5 x. 15 divided by 5 is 3. I don't want to divide that out. When you're doing things in slope-intercept form, it's almost normally a lot easier just to leave it as a simplified fraction. Okay. So now we have a nice, pretty slope-intercept form. 2/5, that's your slope. That's your y-intercept. That's your starting value. So we go to graph this. We're going to go up to 3. From that point, that's on the y-axis. That's why they call it the y-intercept. From that point, we're going to go rise 2 and run 5. So we're going to rise 2, run 5. Rise 2, run 5. Now, if you're going to go ahead and draw that line, take your straight edge out and draw it that way. Now, notice what you're doing as you go through these, that you could have also went down 2 and left 5 and down 2 and left 5, and you could get those. That's a negative and a negative movement, which still gives you a positive movement. So there you go. Right. So let's do another one of those. So we have standard form, 8x minus 2y equals 10. So remember, we want to isolate y. So to isolate the y, I need to get rid of this positive 8x. Notice that 8 is positive, so we're going to have to subtract 8x from both sides. So what we're left with is negative 2y equals, now I had to subtract 8x, so that's a negative 8x and a positive 10. Now some people would write that as 10 minus 8x. Not wrong, but not necessarily the best way to do it. Now I have this negative 2 times y. You got to remember that's negative 2 times y. What I see people doing wrong here is they try to add 2. Well, that's not a y plus 2. That is negative 2 times y. So to get rid of the times, we have to divide by negative 2 all the way through. Gandhi? So what we have is we have y equals negative 8 divided by negative 2 is positive, so 8 divided by 2 is 4x. 10 divided by negative 2, that's positive 10 divided by negative 2 is negative 5. So we have y equals 4x minus 5. So we're going to put that in slope-intercept form, it is, and now we're going to graph it in that form. So we start at negative 5 on our y-axis. Now my slope, remember, if it's just a whole number, it's 4 over 1. 4 divided by 1 is 4, so we rise 4, run 1. So we go up 4, 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. Okay. We could also go down 4 and run 1. and that would work out as well. That's a negative and a negative movement, so we'd be positive there. Okay. Graph your line, extend it the whole length of the way through the coordinate plane, and don't forget your arrowheads because it will go on infinitely. One more of those, and I think we'll be good to go. So we're going to look at the, let's do this first one here, or number 24, x minus 4y equals 8. X minus 4y equals 8. So again, the first thing we want to do is we need to move x over. So now notice x is over here, it's positive. So when I move it over here, it's going to be negative. That's just kind of one of those things. You don't even need to show that. If it's positive x here, it's going to be negative x over here. On the last one, it was positive 8x here, so it became negative 8x on this side, but then we divided it by negative 2, which made it positive again. But so we have negative 4y. Now remember, that is negative 4 times y, not negative 4 plus y. On the right side, let's put the x first, so that's a negative x first, positive 8. My next step is let's get rid of that negative 4 times, so we're going to divide by negative 4. We're going to divide every term by negative 4. Alright, got to be real careful with them signs here, we'll make a mistake. So we're going to go y equals. Now, pay attention to this one. This is a negative and a negative, which makes it positive. That's a fraction. That is not 4. Remember, what number is in front of this x is a 1. So that is 1/4 x. Now, that's a positive divided by a negative, so that's going to be negative 2. So there's our equation in a nice, pretty slope-intercept form. So we go to graph this. We're going to go down 2. Sorry, negative 2. And then we're going to go up 1 over 4. Up 1 over 4. We go down 1 over 4. Down 1 over 4. And we can sketch that line, use our straight edge, draw it right through all those points that we just drew, put your arrowhead on the end, and we're good to go. Okay. So that is graphing when we are in standard form. We can put it in slope-intercept form. You may have learned a way to go from this to the graph last year, but I'm not going to show you that right now. So just put it in slope-intercept form and go. So your homework for today would be the worksheet 0.1. When you're putting in slope-intercept form, make sure you're very careful of those signs all the way through. And good luck if you do have questions. See you in seminar or before or after school.